Assalamualaikum and hello everyone. Welcome to the video for chapter 2 thermochemistry. In this video, we will learn to explain endothermic and exothermic reaction using energy profile diagram, state the standard condition of the reaction and define enthalpy and standard enthalpy. We will define and write thermochemical equation for the following enthalpies, which in this video we're going to look at for the formation, combustion, atomization and neutralization. So without further ado, let's look what is meant by enthalpy, the name of our subtopic itself. Okay. Enthalpy is the heat content of a system or the total energy in the system, where the change in enthalpy is also known as the heat of reaction. So here we have heat of reaction equal to enthalpy change. Remember, enthalpy, the layman word for it is actually heat. Enthalpy is heat. But then for this chapter, we will call it as enthalpy. H lah. Okay. The enthalpy of a reaction, delta H, is the difference between the enthalpy of the product and enthalpy of reactant. Okay, previously, what we have learned in 1.2, delta H is the activation energy forward minus activation energy reverse. But for this chapter, for example, if the heat or the enthalpy of the product or reactant is given, so how we're going to find out delta H? It is the enthalpy product minus enthalpy reactant. Remember, enthalpy is the same as heat. Okay, so let's look back about our energy profile diagram. We have two. One is exothermic, one is endothermic. Okay, for exothermic, it is heat released by the system to its surrounding. So what happens is, at the start of the reaction, our heat or the reactant, the heat of the reactant too is considered high. Okay, once the reaction progress, the heat of the system will decrease lah, or the heat of the product will decrease. Why? Because heat is released to the surrounding. So the heat of the product or the enthalpy of product will be lesser than the enthalpy of the reactant. So when we calculate the delta H, because the product is smaller than our reactant, hence we will get our enthalpy to be a negative value. So that's why for exothermic reaction, it is a negative value. Delta H is equal to negative. Next, for the endothermic reaction, is actually heat is absorbed by the system from its surrounding. So at the start of the experiment, we do have our heat of the reactant, but the heat of the product will be higher than the heat of the reactant. The enthalpy of product is higher. Okay, why? Because the heat is absorbed by the system. So that's why the enthalpy of product will be higher than our reactant. So when we calculate our delta H, H product minus H reactant, we will get a positive value. Delta H product is higher than the reactant one. Okay, so that's why our endothermic will be a positively value. Okay, so that is for the exothermic and endothermic. Okay, next we're going to look at is the definition for the standard enthalpy of reaction. Okay, so for the standard enthalpy of reaction, we're still going to write down delta H naught. Naught, it means that it is our standard reaction. Okay, so this is the general definition. Is the enthalpy change for a particular reaction that occurs at standard condition. What is the standard condition? It is at 298 Kelvin, the pressure is 1 atm, and the concentration is 1 molar. Okay, so this is actually the general definition for the standard enthalpy of the reaction. Okay, next page, what we're going to look at is actually a different type of reaction, and then we're going to apply it into the definition itself. It's quite specific. So let's look on your notes on page 2. Okay, so page 2 here. The first one is the standard enthalpy of combustion. So again, standard enthalpy of combustion, it means we have our delta H, and then not here, it means that it is a standard condition. C stands for our combustion. Okay, so that is the type of enthalpy. So what about the definition? Each different type of enthalpies, we will have a specific definition. Okay, for the standard enthalpy of combustion, it is actually the heat release when 1 mole of substance is burned completely in excess oxygen under standard condition. So again, we have to mention the standard condition is 298 K, 1 atm, and 1 molar. Okay, for this case, it is very important for you to write down what is the 1 mole, because different enthalpy will have different 1 mole lah. In this case, here it mentioned 1 mole of substance is burned completely in excess oxygen. So our 1 mole here must be our reactant. Okay, and then from the definition itself, it mentioned the heat release. So when the heat release, our delta H must be a negative value. Okay, so without further ado, let's look for the equation. Okay, so first what we have is actually the combustion of our carbon solid, which is our graphite lah. Okay, in this case, remember for the definition itself, we know that 1 mole must be reactant. So we have our carbon and oxygen. But then remember, because here it mentioned in excess oxygen, so it means that that is not 1 mole lah. It could be 1 mole of oxygen, but based on the definition, the 1 mole must be our reactant, the other reactant besides our oxygen too. Okay, in this case, our reactant is our carbon here yang must be 1 mole. So here I'm just going to write down 1 mole of carbon. Okay, so from here then we can balance the equation. So once we have 1 carbon, so here must be 1 juga lah, because here my CO2, and then my oxygen here is 2, and my oxygen here is also 2. Okay, so this case, my oxygen is 1. Okay, so that is actually our thermochemical equation. And when we look at our delta H, we have to write down delta H, not C, stands for combustion, is a negative value because heat is released. Okay, so that's the first one. Okay, but then for the this is actually specifically for carbon lah. But for general combustion, the product what we have is actually CO2 and H2O. Okay, so how to make it balance? The order of balancing, we have to balance carbon first, then balance the hydrogen, last one balance the oxygen. Okay, let's look next is our CH4 plus O2. Okay, which one we're gonna do it as 1 mole? Okay, because here you mentioned excess oxygen. So for sure, not here that must be 1 mole. Here must be my 1 mole. So here is 1 mole. Okay, next, how to make it balance? First balance carbon dulu. Here carbon 1, here pun must be carbon 1. Next, balance the hydrogen. Hydrogen, here is 4, here is only 2. So we have to write down here 2 to get 4 hydrogen. Last but not least is the oxygen. So here I have 2 oxygen. Here I have 2 oxygen. Okay, so how to make it balance? To get 4 oxygen, here we have to write down 2O2. Okay, so that's the second equation. The last equation for the combustion. Okay, which one more? The reactant. This one. Okay, so from here, make sure carbon is balanced. Here is carbon 2. Here, we have to write down 2. Next is hydrogen. Okay, please take note, this is actually alcohol, our ethanol. So here is not H5, we have another one. So hydrogen here 6, here is only 2. So how to make it balance? Times dengan 3. Okay, so last but not least is the oxygen. So oxygen here 3, oxygen here 4, total we have 7. Okay, but then when you balance the oxygen, make sure the reactant ni ada oxygen ke tidak. Okay, so here we have 1 kan? We have 1 oxygen. So here, it means that our oxygen here must be 6. So when here is 6 oxygen, so we have to write down here 3 oxygen. So right now, here 1, here 6, here 4, here 3. So the oxygen is balanced. So make sure whether sometimes the oxygen is also written down in your substance, the other reactant as well. So make sure lah, the equation is balanced. Okay, so that is for our enthalpy of combustion. Okay, next is standard enthalpy of neutralization. So for the neutralization, okay, still delta H not, and then we have small n, stands for neutralization. So the definition, the heat release, still heat release, so delta H will be negative. When 1 mole of water is formed from the neutralization of acid and base under standard condition. Okay, so here, product here, 1 mole is our product, tapi specific lagi which product, it must be the H2O that have to be 1 mole. Okay, in this question, we have HCl with sodium hydroxide. Okay, we do get NaCl and H2O. So here, we do get 1. Okay, remember that H2O ni is actually H dengan OH. H must we get from our acid, OH from our base. Okay, and then as we can see, here hydrogen only 1, OH here pun 1. So we do get our H2O. So here 1 ratio, and NaCl 1 as well. Okay, because this reaction the heat release, so our delta H is a negative value. Okay, next equation we're going to look at is H2SO4 with NaOH. We get H2O plus Na2SO4. Okay, so which 1 mole? 1 mole is from here. Okay, remember for the reaction, H we get from our acid, OH we get from our base. Okay, so OH here we do get from straight away here. But then for the case of our acid, okay, we only need 1 hydrogen. But H2SO4 here hydrogen is 2. So how are we going to make it balance? So from here we have to write down 1/2 because the H we only want it as only 1 hydrogen. Ini ada 2 kan hydrogen kan? Right now ada 2. But when we write down half, so we get only 1 from here and OH from here. Okay, so now is 1. Okay, but then how about the product? The other product, our Na2SO4. From here, our Na2, we have 2 of my sodium. But from the reactant, it's 1. So how to make it balance? It is 1/2. Okay, so this is the standard enthalpy of neutralization. Okay, so make sure for the enthalpy, write down which one is 1 mole. Okay, this is the enthalpy of neutralization. If you gonna multiply it by 2, for example, here we get 1, 2, 2, 1, kan the ratio, you will not get a standard enthalpy of neutralization lah. Just remember, the definition must be 1 mole of water. So this is actually the equation. Even though the number does not seems very pretty kan, ada fraction kan. But that is the correct answer based on the definition. Okay, next we're going to look at is the standard enthalpy of formation. Okay, so for the standard enthalpy of formation, here it mentioned the heat change when 1 mole of compound is formed from its most stable element under standard condition. So here, when it mentioned heat change, it could be negative value, it could be positive value. But for the neutralization and the combustion, specifically heat release. Okay, for the formation, okay, instead of small n or small c here, formation, small f lah pula, cell delta H, not to mention that it is standard condition. Okay, from here, it mentioned the heat change when 1 mole of compound is formed, when 1 mole of compound is produced. So in this case, 1 mole must be our product. Okay, but then for the formation, the tricky part is actually here, from its most stable element. So please write down in your note what is the stable element. So for example, group 1, 2, 13, 14 must be solid lah. The famous one, carbon lah, group 14. Originally it's from solid. Contohnya we have our lithium, sodium, potassium, group 1, group tu apa lagi? Be, Mg, all of it. Group 1, 2, 13, originally it is a solid. Hanya satu sahaja. Okay, but then for group 15, 16, 17, originally it's gas. So bila the gas ni, dia jadi N2, O2, F2. Ini group 17 lah. F2, Cl2, Br2, I2. Originally, the stable element is actually a gas and it's Cl2. Okay, why? Because actually the atom here have covalent bond where the 2 atoms share the electron to achieve octet. Okay, sebab tu the stable element for this group 15, 16, 17 is actually a diatomic molecule. Okay, and then have to take note juga hydrogen. Originally dia from H2 gas. Sebab dia pun share 1 electron here, seorang ni share 1 electron. So the stable element is H2. Okay. So without further ado, let's look for the example. So this is the enthalpy of formation of H2O. So H2O originally dia from, kalau kita tengok dia mestilah H dengan O kan. Okay, but then kalau hydrogen, dia mesti yang H2. So that's why here H2. Oxygen from our O2. So that's why the equation dia H2O2. Okay. But now what we're going to do is actually how to make it balance. So 1 mole of product here. Okay. So when 1 mole of product here, make sure the reactant is also balanced. So here we have 2 of my hydrogen. So here pun must 2 of my hydrogen lah. Okay, next oxygen here is only 1, but then kat sini ada 2. So what we're going to do? Half of O2. Okay. So that's the first one. The second one, let's look. C2H4 gas. Okay, kalau C2H4 originally must be carbon dengan H kan? Okay, carbon originally memang stable state dia solid, carbon solid lah. So that's why here, yang hydrogen pula, stable state dia is H2. So that's why kita write down sini H2 gas. Okay, next is balancing the equation. So 1C2H4. Okay, carbon kita tengok. Carbon is 2. Okay, hydrogen is 4. So here is only 2. So kita write down 2H2. Okay, next equation we're going to look at is NaCl. Okay, NaCl originally Na dengan Cl lah kan kita nampak. Okay, Na memang originally group 1. So Na solid. Tapi Cl, stable state dia sebenarnya Cl2 gas. Okay, so dekat sini, Na, here must be yang solid tu, kita tengok colour biru tu. Cl2 dia kat situ dah tulis dah. Cl2 sebenarnya generally gas. Okay, so which one yang 1 mole? Here 1 mole NaCl. Okay, here 1 mole Na, but my Cl2 is not balanced. Half. Okay, contohnya, satu lagi. Just gonna write down. So originally, okay, the product is Li2O solid. Okay, originally mestilah lithium. Okay, dengan oksigen. Okay, lithium. Lithium kita tengok stable state dia solid. So here Li solid. Okay, oksigen, stable element dia. Sebenarnya from here, yang gas, O2 gas. So we're gonna write down O2 gas. Okay, next make it balance. So here Li2O sini yang 1 mole. So right now lithium is not balanced yet. So 2 here. Lepas tu our oxygen dalam case ni is only 1. Tapi sini ada 2. So we're gonna write down this one as half. Okay. So equation formation ni, okay, yang confused dia is actually here, the stable element. So please write down on your notes. Okay, the last part for the enthalpy of formation, here it mentioned that the standard enthalpy of formation of any element in its most stable state form is 0 because the element is formed from their respective element. Okay, so contohnya, kalau kamu tengok kita punya product and reactant is the same one, so the delta H will be 0. For example, kita tengok lithium lah. So here, lithium solid jadi lithium solid. Contohnya, okay, formation of lithium solid. Okay, dia punya stable element pun, kita tengok. Group bond kan, solid juga. So, lithium solid. So, sini delta HF kita is equal to 0. Okay, kalau stable element, memang dia jadi 0 lah. Originally. That is what is meant by this statement. Okay, last one, kita akan tengok standard enthalpy of atomization. So for the atomization, delta H not A. Okay, so here it mentioned the heat absorbed. So heat absorbed, heat will be a positive. The delta H must be a positive value. When 1 mole of gaseous atom is formed from its most stable element under standard condition. Again, it is involving our stable element lah. So stable element, here is the notes. I have written down juga sini. Okay, dalam case ni, the 1 mole must be product. Okay. And then, the product must be in gaseous state. Gaseous atom. Atom. Ini satu saja. Cl2 is not atom. Cl atom. H2 is not an atom. Atom must be 1. This one is actually an atom. Only 1. Okay, so for example, what we have here. My Cl2 becomes Cl gas. Again, 1 mole of product. And it must be an atom. So, betul lah. So, here is 1 mole. But then, from its stable element, the stable element is Cl2. This one. So, that's why dekat sini, Cl2 gas. To make it balance, it will become half. Okay. So for example, kita tengok ini, the product is 2F. So 2F, it means that it is not an enthalpy of atomization. Even though it seems macam yalah sebab ada satu yang ini, and the original one is our stable element kan, but it is not our enthalpy of atomization. Yang ini we denote is as delta H sahaja dulu. Okay, but then when we divide this by 2, so we get half F2 to become F gas. Now this is what we call enthalpy of atomization. Why? Because 1 mole of gaseous atom is formed from the element. Yang ini pun memanglah nampak macam gaseous atom kan, tapi kat sini kan 2. So taklah. So yang ini baru enthalpy of atomization. Yang ini barulah denote the delta H not A. Atomization. How about the value? Since this one is 270, okay, yang ini kan half of this equation. So the value pun half of this value. So it become positive 135. Okay. Last one here, it mentioned that the enthalpy of atomization is equal to enthalpy of sublimation. Certain question give it to you the enthalpy of sublimation. Okay, why? Because for the specific element, sometimes it only changes the phase sahaja. The coefficient sama sahaja. For this specific case, is actually when the phase is changing from solid to gas. So for this, for example, we have our sodium gas. Okay, here jadi 1 mole. Okay, tapi originally, the most stable state dia bukannya Na2 gas, it's not. Kalau sodium, group 1, dia memang from our Na, tapi dia solid. So, what is the changes is actually the state itself. So, yang ini, from solid to gas, is what we call sublimation. So, that's why it also, as sometimes it is called enthalpy of sublimation. Okay, last one, yang ini, sengaja je. We have our nitrogen gas. Okay, originally, memang 1 mole of nitrogen gas lah kan. What is the stable element? Stable element is N2. So, N2 dekat sini is actually N2 gas. Is it balanced? Not. This is only 1. Yang ini ada 2. So, how to make it balanced? Here, we have to write down half. Okay. Okay, so that's it for this video. It's important for you to know which one is 1 mole. And for the formation and the atomization, it's important for you to take note what is the stable element.